record it here. So 7.4 is scale drawings. Scale just means the ratio that compares the measurement of the model or drawing to the real object. Okay, so if it's like 1 to 2, or maybe it's 4 to 7, something like that. It's a ratio that compares the measurement of the model or drawing to the real object. Okay? So example 1 is a picture, and I'm going to show you. There's a picture of a map on page 576. So we use scale in maps like all the time. Okay? And if you grew up, you know, like I did 100 years ago, you actually had to look at a paper map anytime you went anywhere. So I remember going on road trips with my parents, and they would get out like a big old atlas, and my mom would have like all these maps like everywhere, because she was like the navigator and my dad was the driver, you know. And so she would like have everything like highlighted on the map, like where we're gonna go. And now like we would crack up if she did that, right? Because we have Google Maps, and we use our iPads and our cell phones to find where we need to go. So, and then we have a voice that tells us, which is crazy, right? So here's a picture I want to show you guys. Okay, so this is the work, but I'm going to show you the picture first, and then I'll put it back. So basically, this is on 576, and they have this map. This is an old school paper map. It says, what is the actual distance between Hagerstown and Annapolis in Maryland? So here's Hagerstown, and there's Annapolis. And it says use a centimeter ruler. Okay, so you would like measure it with a ruler. But see here how it has a scale? 1 centimeter to 24 miles. Okay, and it says this map is about 4 centimeters. Okay, so how would we get from 4 centimeters to miles? We would multiply by 24, right? Okay, so there's the picture, and then here's the math. So what they did was they said, okay, the map is 1 centimeter, right, is 24 miles. And then they said the measurement is 4 centimeters, and I need to figure out D miles, D for distance, okay? So you're going to set these up pretty much the same way. However, this one's pretty easy. We know we can just multiply by 4. But remember that cross-multiplying divide thing? So this is what you did in 6th grade when you set up a lot of proportions. So you would say 1 times D equals the 24 times 4. So that's 96 miles. Now, do you need to set it up like this every time and do all this work? No. If you already know, okay, well, 4 centimeters, 4 times 24, 96, then you're good. As they get more challenging and we introduce like fractions and decimals, you'll probably want to set something up though. Yes?
Does D equal distance?
Yeah. Okay? So that's the map one. Are we okay with that one? Real basic? Okay. The next one is a scale drawing of a phone. I'm going to show you that first. It's on page 577. This is an old school phone. Some of you probably have seen these. All right? It's a flip phone. So basically this one here, this one has a scale drawing of a phone, and it says that they're making an advertisement, and it's 5 inches equal 1 inch, okay?
Who would want to buy that?
I don't know. So 5 inches is the advertisement, and then they want to figure out here, write a proportion using the scale. They want to know the length of the advertisement, okay? So this is the setup. So here's the picture, and then we have 4 inches, and you guys already see, all of you are going, I know, 4 times 5, right? You already know that, okay? So the length of the cell phone on the advertisement is 20 inches, and then here's the math. So that was the picture. Here's the math again. So the ad is 5 inches, the actual is 1. Okay, then we don't know what the ad's going to be, so we just put A for ad, inches, and then we know that the actual is 4 inches. So when you cross multiply, you would get 20. Okay? So those two problems are basically the same setup, right? Just cross multiply. Okay. Now the scale factor, which is what we were investigating as well, is a scale written as a ratio in simplest form. Simplest form is kind of key there. That means simplify your fractions, right? Scale factor, you have to write in simplest form. Okay, so an example, if they said find the scale factor of 1 inch equals 6 feet. If 1 inch equals 6 feet, this is how we would figure this out. You guys remember when we did these little bit of, we did unit conversions earlier in the year? Remember we'd go from like miles to kilometers and stuff like that? Yeah, this is real basic though. This isn't going to go into that crazy stuff, okay? But this is pretty easy though, because you know 1 inch is 6 feet, and then you just put the 1 across the top here, and 6 feet is 72 inches. How do we get from 6 feet to 72 inches? Multiply by 12, right? Because there's 12 inches in a foot. Okay? So now that's just 1 over 72. That's the scale factor. Okay? And obviously this is in inches now, right? Now, we rarely do it this way, right? Like on paper or even in our brain, we're already thinking, oh, 6 feet is 72 inches. We do that, right? So we rarely actually have to write it as a ratio. So I wanted to show you guys that, because on your test it will be asked in that form. So you know what when you see a 1 over something, you're like, oh, that's what I need to do. Okay. What if you put 72 over 1 right there?
Yes.
Would it be going from, if you put 72 over 1, you're going to get really big, right?
Yeah.
Okay, but we're trying to like figure out our inches and our feet, so we're going small. So that's why it's a fraction of 1 over that. Good? Okay. All right, so example 4. This is the bedroom plans example. I'm going to show you what this looks like on 578. Okay, so this one actually has a blueprint. I'll show you here. So you can see on the left, you guys see it? This is what a blueprint might look like. I mean, this one's not as crazy intense as a regular blueprint. Does anyone have you guys seen blueprints of your house ever? No. Or someone's house?
I have.
Okay.
My uncle's.
Cool. So this has all these different rooms. This is like the long skinny house here. A floor plan for home is shown at the left, where 1/2 inch represents 3 feet. What is the actual area of bedroom 1? So you would go to bedroom 1. Here's bedroom 1. Okay, and then we have, this is 1 by 4. Okay, bedroom 1. But we're supposed to go 1/2 inch equals 3 feet. Okay? So what they did for the length, they do separately than the width, okay? The length, they would do 1/2 inch over 3 equals the 4 inches right here. Here's the length over W for width. Or sorry, for the missing piece, okay? So this is just going to be cross multiplying and dividing. I'm going to show you in a minute. This one, the width, 1/2 over 3, same thing, but the width is only 1 inch, right? And so then they do some work here, cross multiply to get 6, okay? So then the area, you take those new numbers, this 24 times the 6, and that will give you the 144 square feet, okay? So they're basically getting the scale right, and then they're multiplying. Does anyone think of an easier way to do a problem like this? Does anyone think of something easier that you could do? When you're finding area, what do you do? Yeah, so do you think that maybe you could find that first and then work backwards?
Yeah.
You probably could do that. So here's the math, okay? We have a good example here. So for the length, For the length, what they did was they took the 1/2 inch that equaled 3 feet, right? That's what it said in the problem. And then the length of the room was 4 inches, and then the W is just my missing piece, okay? So when I cross multiply, I get the 1/2 times W, and then the 4 times 3. So that's 1/2 W equals 12, right? 4 times 3 is 12. And then you remember cross multiplying, so 2 times 12?
Yeah.
24. So that's the math. So this right here, this first setup on the left, this is the scale factor, right? This is, could you write 0.5 over 3? Yes. If you don't want to deal with fractions, you can make them decimals. Then to get the width of the room, same scale factor, except the width on the blueprint told me it was 1 inch. So I write 1 inch there instead of 4 inches. And then I cross multiply. So that's 1/2 x equals 3 times 1, which is 3. And then cross multiply is 6. So when I'm finished with that, to get the area, 24 times 6. Okay? The problem appears harder than it is, right? But you're always setting up the scale on the left side, and then whatever the actual is will go up here. Okay? Okay, so we are going to do some practice because I know this just looks crazy right now, right? It just looks like a bunch of numbers. So we're going to practice and make sure that you guys can apply it. So on page 579, we are going to do 3 and 4 together. And then after that, we're going to do 580, number 7. Okay? So we're going to turn to 579. There's actually, I only gave you guys 5 problems for homework tonight because I know you have to do the measuring too. But if you want to write this in, this has the homework stuff. So if you guys like it in your notes, some of you write it in your planners, but if you want it in your notes, it's there too. It's the same stuff that's on the board though.